Today we're covering standards that deal with functions. We're going to cover standard F1, F3, and F5. Standard 8.F.1, is it a function? So we're going to start with the definition of a function. In a function, each input, x, has exactly one output, y. So every x has exactly one y that goes with it. So looking at this problem number 1, select all the relations that represent a function. So each x has exactly one y. If we look at this first set of ordered pairs, we have an x3 that has two outputs, 2 and 9. So this one is not a function. If we look at the next one, we have x coordinates that are all different, 1, 2, 3, and 4. So yes, this is a function. Each input has exactly one output. For this next one, all the x coordinates are different. So each input, x, has exactly one output. So yes, this is a function. For this next one, each x is different. So each input has exactly one output. So yes, it's a function. Then for this final one, the 2's repeat on the x's. So the x input of 2 has 4 different outputs, 2, 5, 1, and 3. So no, that one is not a function. Number 6, does the graph shown represent a function, or is it not a function? So we're going to try the vertical line test. And this just says that a vertical line can only cross through one point at most at a time through a graphed equation. So it only crosses one place here, it only crosses one place here, and we can just keep on drawing vertical lines, but you'll see that there's nowhere that we could draw a vertical line on this graph that crosses more than one place. So this is a function. Number 8, is the given relation a function? Use the graph to explain. Well, let's go ahead and graph these points. We have 1, 5, 2, 1, 3, 7, 3, 2, and 4, 6. If I draw a vertical line through these, I have a place right here where a vertical line crosses 2 points. So no, this is not a function. And we can tell because we have these ordered pairs, 3, 2, and 3, 7. Each x3 has more than one output, more than one y, 2 and 7. So no, it's not a function. Is the relation shown in the table a function? Yes or no? And explain. We'll look at our inputs. We could also call these x and see if we have exactly one output, one y. Notice that your x, we have 1, 3, 4, and 9. They don't repeat. They each go with exactly one output. So yes, this is a function. Standard 8F3, if you skip over a couple pages, is it linear? We are looking to see if we were to look at a graph, if it's linear, it just means that the whole graph is a straight line. If we were looking at an equation, it's going to be able to be written in the form of y equal mx plus b. So let's start with this problem number 3. Select all the functions that are nonlinear. Okay, so it means not a straight line. Well, this first one is a straight line. So this one is linear. Our second choice is a graph. Well, if it's linear, we're going to have a constant rate of change. So let's go ahead and find the slope and see if it's the same throughout, where the change of y divided by the change of x is the same. So we'll start with this change of y. For negative 12 to negative 7, it increases 5. And from 0 to 1, the x increases 1. It gives a slope of 5. From negative 7 to negative 2, it increases 5. From 1 to 2, the x increases 1. So we've got a slope of 5. From negative 2 to positive 3, it increases 5, and the x increases 1. So we've got 5 divided by 1, which is 5. Okay, the change from 3 to 8, it increases 5, while the x from 3 to 4 increases 1, so it goes up 5 over 1, which is 5. So notice that the rate of change in every one of these, 5, 5, 5, and 5, is the same. So it is constant rate of change, which tells us that it is linear. That's just a fact. The slope is the same, so we're talking about a straight line. So this one is linear, so we move on. Our next choice, y equal 2x plus x cubed, we have x raised to a power. This has got an x to an exponent other than 1. That makes this non-linear. So we would mark this answer choice. Our next choice is a table. So once again, we're going to find the change of y over the change of x and see if it's constant or not. So y goes up 12 when x goes up 1. So 12 over 1 is 12. Y goes up 12 when x goes up 1. So 12 over 1 is 12. 24 plus 12 equals 36, so we add 12 for the y when we add 1 for the x. So 12 divided by 1 is 12. And then the very last one, 36 to 48 goes up 12 when 3 to 4 goes up 1. And 12 divided by 1 is 12. So we have a constant rate of change, which tells us that this table is linear. So we wouldn't mark it because we're looking for nonlinear. This next choice is a graph. Notice that it looks like it's linear here, but then the line bends, it turns. So it's not an entire straight line. This is nonlinear. Our last choice is an equation, and notice it is in the form of y equal mx plus b. So this is linear. Number 4, select all the functions that are linear. So this time we're going to mark the ones that are linear. So looking at this first one, we could use the change of y over the change of x since we're dealing with a table. Y goes down 150. It's a decrease, so we subtract when x adds 5. And that reduces to negative 30. Now y goes down 50 when x increases 5. So down 50 when x adds 5 is negative 10. Notice that our rates of change are not the same. So this one is non-linear because we are getting different rates of change. They're not constant. That indicates this is not a line. This will have a curve. The next choice, y equal 8x plus 5, is in the form of y equal mx plus b. So this one is linear. Now we have a graph. Notice that it's a curve. It's not a straight line. So this is non-linear, not a line. Now we have a table. Let's see what the change of y over the change of x is. So for y, we go up 0.1 when x goes up 1. 0.1 over 1 is a change of 0.1. Then we have y goes up 0.3 when x goes up 1. We have a change of 0.3 over 1, which is 0.3. Notice that we're getting different rates of change. So this is going to be non-linear. This next choice is an equation. We can't tell by looking at it if it's linear for sure. It appears to be linear, but we need to rearrange it into y equal mx plus b. So we're going to box in our y term and get rid of our x term, 2x, by subtracting 2x from both sides of the equation. we get negative 3y equal negative 2x plus 24. Now we want to divide both sides by negative 3 to get y by itself. So y is equal to negative 2x divided by negative 3 is just a fraction. We'll pull 2/3 out front, and negative divided by negative is positive. So we get positive 2/3 x. And then positive 24 divided by negative 3 is negative 8. Notice that this is now in the form of y equal mx plus b, so it is linear. Okay, this last choice we have a graphed line, and it is just a straight line, so it is linear. Our last standard today, 8.F.5, this is about characteristics of graphs. So we're going to start with problem 1. Which term best describes the graph of y equal negative 5x plus 1? Increasing, constant, decreasing, or positive? So notice that this equation is in the form of y equal mx plus b. And we want to look at m. In this case, that's negative 5. So m, the slope, is negative 5. That means that on a graph, this line will go down to the right. And we would describe that as decreasing. We read graphs from left to right like we read words on paper, so it's going down to the right, which is decreasing. Number 4, for each type of graph, increasing, decreasing, and constant, choose the correct description of the slope. Well, we just said that if it's decreasing, that it's got a negative slope because it's going down to the right. If it's increasing, it's going up to the right, so it's going to have a positive slope. Constant means it's going perfectly across in a horizontal segment, a line segment, and that would have a slope of 0. Problem 5. The graph shows how a motorboat travels around a lake. What does the graph most likely show? Notice that it's starting at a certain speed, and it's constant, and then the speed drops over time. So, A says the boat travels at a constant speed for 10 minutes and then stops. B says the boat travels at a constant speed for 10 minutes and then slows down. That seems reasonable. We'll just double check the others. C says the boat steadily increases its speed for 10 minutes, but that's not true. D says the boat steadily increases its speed for 10 minutes, and that's not true. It starts at a constant speed and then it slowly drops, so answer choice B.